The marching ants activity is a really good example of unplugged computational thinking. And I can guarantee that you will have all started off and attacked this problem with the brute force attack without actually thinking about computational thinking. To solve this problem and any other problem really, we need to apply computational thinking. And it's a simple process of identifying the problem. So we've identified here the problem is that the ants have to interchange, move from one side to the other. So the red ants need to move to the right and the green ants need to move to the left. And they need to do that following an algorithm, a simple rule. In other words, an ant can only move into a space on the opposite side of another ant if it's free, and they can jump over one ant of a different colour. So we know we've been successful by defining the outcome when the red ants are on the right-hand side of the ladder and the green ants are on the left-hand side. And when you go into the brute force attack approach to problem solving, which is what most students do, you haven't decomposed the problem. And this is when problems begin to happen. You get stuck. So the first thing we need to do when we are presented with a problem is try to decompose it to its simplest form. So here we have decomposed the problem into its simplest form. We simply have the simplest version of this solution is to have one ant passing another ant. So we can now apply the rules. An ant can move into an empty space, and we know that an ant can jump over another ant if there's an empty space on the other side of it. There we have it. We have solved the problem. The red ant has moved to the right and the green ant can move unimpeded to the left. We have decomposed the problem into its simplest form. And this is what we need to get students to do, is to decompose those problems, identify what the simplest version of this is. Can we spot any patterns? No. If we come back to here, there's not enough information to pattern match, but we've certainly decomposed the problem. So the next thing now is we need to pattern match, which now means we need to go around our cycle here and decompose the problem to its next most complicated value. So if we come back down to here, we can now see, let's try this again. Let's look at this. We can slide the green ant into this space here. We can slide the green ant up to here, and the game is over because there's no room for any other ants to move. So we know now, we're beginning to see that there's a bit of a pattern emerging. We need to make sure that there's a space for the opposite colour to move into. Everything's looking okay. So what do we do now? Let's see if we can move that up. And is everything looking okay? Yes. Can we see a pattern? Maybe we can. Maybe we can't. If I'd left this here, could we have still solved the problem? Let's look at this. Gone to here. Yep, we can still do that. We can move to here. Yep. Now we're stuck. So there's a bit of a problem here. Let's come back to where we were. Let's set everything back up again. Let's just prove to ourselves that we can do this. But now we've decomposed the problem into its next most complex form. What we're looking for are patterns. So let's start again. Here, yes, that's working. Move that to there, that's working. Let's move this red one up. Okay, we can still move. Can the green move? Yes, the green can move to here now. What else can happen? We could move this to here, but if I did that, the green would be blocked from moving. So let's not move that red. Let's move the green to here. It's looking promising. What can next move logically? Or the green could move if we wanted it to, but so could this red. And so now that means either the red or the green is free to move. So we've now moved the red to here and the green can move on and the ants have interchanged. So we now know that the problem works with the next most complex thing. And so hopefully we would have spotted some patterns. And so we now have decomposed the problem. Next stage is to make it the next most complex solution and then really begin to identify if there are any patterns that we can look at or any rules that we can generate. So now we're making the situation a little bit more complicated. We've now moved the more ants onto the ladder, so we can now working with the next most complicated solution. So we've decomposed it upwards, the least complicated to increasingly complex, and we know how to decompose the problem. Hopefully, we're beginning to see how to pattern match. And now perhaps we can begin to see that we can create an algorithm. So let's see if we can do this. Let's look at this. Let's slide, click on here, let's slide a green into space. That's looking good. Let's move or let the red ant jump. Now we need to maintain a pattern. Can we begin to see a pattern? So obviously if I move this into this space here, we can then let the red ant jump, but we know if we get two ants together in the middle here, we've created a blockage. These green ants can't jump. So we've worked ourselves into a corner. But we do know that using two ants, we have a solution. So now we need to start looking for these patterns. So let's look overtly for these patterns. So let's start again. Green moves into this space and the red can jump over the top. Now this red can slide into that vacant space, and can we begin to see a pattern? Maybe, maybe not, but maybe things will become more clear if we now think that this green can jump into this space. So we've got a sequence of jump and slide, and this one can jump, that's good, and this one can slide. Can we see a pattern? Yes, there are two patterns here. We've got a jump and slide pattern going on here, and we've also got alternating colors. Does that help us? Well, let's have a look. The red can jump over the green, that looks good. This red can jump over the green, that looks good. And this red can jump over the green. And have we maintained our pattern? Alternate colors? Yes, we can. Yes, we have. And can we continue to move now? The greens can slide, so we've got another pattern emerging here. We're alternating the moves. That can jump over, that can jump over, that can slide, and that can jump. And our ants have interchanged. So we've now decomposed our problem at the next highest level. Let's see if we can now create an algorithm and abstract that rule to make sure that we can do this for any number of ants on any length ladder. So if you're not ready for the solution yet, this screen here is the place that you hit the pause button. But if you want to know how to solve the challenge, let's go to the next slide. So here we go. Here are our 5 ants. This is where you all first started, and you all attacked it with your brute force attack without decomposing the problem, without doing any computational thinking. So now we've applied some computational thinking rules, we've decomposed, we've pattern matched, we've created simple algorithms and tested them and refined them. We can now create, or have created, an abstracted rule of pattern matching in terms of making sure that the colors alternate, that they follow a pattern of sliding and jumping, and that the other pattern is that the colors alternate in their moves. So let's move first. Let's move the green first into this space. Now, because I've moved green, I now know I need to move the red. So let's move this into here. Now we can slide this one up because that's still a legal red move. Now we can jump this one over. We can jump this one over, and we can slide this one up, which now means that we can jump this red one over because we're alternating. We can jump this red one over. We can jump this red one over, and we can slide the last red up, and we can see our alternating pattern here. So now let's move the green over, it's jumping over, and jumping over, and of course the last move is a slide, so that moves to here. Now it's the red move. Can the reds move legally? Yes, they can. Into the end space, we've got our first red ant out, move over to here, and move over to here, and move over to here, and then finally move over to here, which now means it allows us to now move our first green ant out. It's reached its destination, it's slid, and now we can jump, and now we can jump. And of course, once you see the pattern, once you've decomposed the pattern, you're amazed at how you never understood how you couldn't do it in the first place. But that's because a brute force attack is not often a very successful way to solve a problem, and this is why students give up, because they don't have the smarts to break things down into simple and sequential steps. There we are, and we've solved the solution by applying computational thinking.